Welcome you all. I am Shreenath, Faculty of Mechanical Engineering Department, Canara Engineering College, Mangaluru. In this lecture, I will explain about how to solve the numericals on dimensional analysis. Hello. So this is lecture number 2 on dimension analysis. In lecture number 1, we studied about what is dimension analysis. So what is primary dimensions and secondary dimensions, then dimensions of different variables, and studied some information related to Buckingham pi theorems. On today's class, I will give information related to how to solve numericals in Buckingham pi theorem. So that is one type of the dimensional analysis. Here is one problem. The efficiency of the fan depends on density, dynamic viscosity mu of the fluid, angular velocity omega, diameter d for the rotor, and discharge q. Express efficiency in terms of dimensionless number. See the solution here. The efficiency of the fan is given by eta, density of the fluid is equals to rho, dynamic viscosity of the fluid is mu, angular velocity of the rotor is omega, diameter of the rotor is d, and discharge of the fluid is q. See here, the efficiency, that is a dependent variable. So that efficiency of the fan is a function of other independent variables, that is density, viscosity, angular velocity, diameter, and discharge. So this expression can be written as the function of efficiency, density, viscosity, omega, diameter, and discharge is equals to 0. So here there are 6 variables. So taken as n is equals to 6. So m is the number of fundamental dimensions for the problem. So now write the dimensions for all these variables. So here efficiency, we know there is no dimensions for efficiency, for that reason it is a dimensionless. Then density, it is mass by volume, the unit of that one kg per meter cube, the dimension is m into L4 minus 3, diameter measured in meters, that is equals to L. Then dynamic viscosity, Newton second per meter square, you can write the dimension as meter, mass m into L4 minus 1 T4 minus 1, discharge, that is meter cube per second, that is L cube into T4 minus 1, so omega is equals to 1 by time, that is T4 minus 1. Since these dimensions of variables, the fundamental variables are 3. For that reason the m is taken as 3. So now number of pi terms, the equation is n minus m. So n is equals to 6, m is equals to 3. That means 6 minus 3 is equals to 3. So for that reason the equation 1 can be written, or the equation is a function of what? It is a function of 3 different pi terms, that is a pi 1, pi 2 and pi 3 terms. So that is equals to 0. First 5 terms considered. Pi 1 is equals to rho. So this is the repeating variables rho, omega and d, and give the power of a1, b1, denote the powers a1, b1 and c1. There is no power for next efficiency here, because here pi 1 terms are depend on these variables now. Then Already we know that there is no unit for the efficiency. We directly straight away we can take it as a phi 1 is equals to efficiency. If you want to, in case otherwise one more approach is given here, we can also possible to find out the phi 1 term is equals to efficiency here. So here the first term, we substitute the dimensions of on both sides of the phi 1 terms. So the phi 1 term initially for left hand side is taken as m power 0, l power 0, t power 0. For right hand side, for in case diameter there is L, that is A1, and omega, the dimension of that one t power minus 1, that is power of B1, and third one density, that is M into L power minus 3, that is power of C1, and for efficiency, that is a dimensionless number, that is m power 0, L power 0, t power 0. Equating the powers of M, L, T on both sides now. So first you equate power of M. The power of M is considered on left hand side, the power of M is 0. In right hand side, the only one power M term is available in density, that is M. Let's take it, write it as C1. For first term L, there is no M term. In second omega also there is no M. And in the third density you are getting M, that is M. It can write it as C power 1. C power 1. So now on left hand side that is 0. The remaining one is what? Just right hand side only C1. For that reason the C1 is equals to 0. So similarly the power of L. On left hand side power of L is 0. On right hand side the L power A1 is there. That is write it as A1. Then in omega term there is no L. In third, in density term, there is L power minus 3, and the power of what? C1. It can write this expression minus 3C1. Simplify that. Then already we know that the C1 is equal to 0. That value is obtained in power of M. Substitute there. For that reason, A1 is equal to what now? 0. After simplify that. Next, power of T. On left hand side, power of T is 0. Right hand side, the t power minus 1, b1 is there, that is write it as b minus b1, plus in third term there is no t term. For that reason b1 is equals to now 0. So now we got the values of what? A1, b1 and c1. Substitute these values of a1, b1 and c1 in phi 1 term. The phi 1 term is equals to, see, here L power A1, L power A1 is equals to 0. Then second term, T power T, that is T. So T, there is a B1, power of that one is what? B1. The B1 value is also 0, that is omega also 0, diameter power is also 0. The third term is what? Density. The density, that the power of density is what? C1. So the value of C1 is also what? 0. For that reason, the remaining is what? The phi 1 is equals to efficiency. The same thing got in the very first solution also. Now, similarly, equating the second phi 2 term. The phi 2 term is taken as rho, w, and diameter. These are the repeating variables. The next term is what? Mu. In first phi 1 term, the efficiency is taken. In second phi 2 term, the remaining one is what? Mu. That is viscosity, is dynamic viscosity is taken here. Give the power for these repeating variables as A2, B2 and C2. So now substitute the dimensions of these repeating variables on both left hand side as well as the right hand side. For left hand side, the phi 2 we take it as M0, L power 0, T power 0. On right hand side, write the dimensions of density, angular velocity, diameter and dynamic viscosity. So now you are, for dimensional homogeneity, equate the powers of M, L and T on both sides of the equation. So what you did in first phi 1 term, the similar manner you have to equate these powers of MLT. For example, for M, left hand side M is equals to 0. Next, M power in first density, that is M power of A2, that is A2. Then next one more you are getting M term at viscosity, so that is M. So take it as just 1 year. So there is no power here, for that is taken as a 1. So after simplifying that, A2 is equals to what? Minus 1. So similarly you have to find equate the powers of T as well as L here. So after finding the values of this A2, B2 and C2, substitute these values in phi 2 expression, that is rho power. After getting the A2 value is equals to minus 1, B2 value is equals to minus 1, C2 value is equals to minus 2. Now rho power A2, the rho power A2 is equals to minus 1, omega power B2, B2 value is minus 1, and diameter power C2 is equals to minus 2 into mu is there. Now pi 2 term is equals to the rho power minus 1, omega power minus 1, d power minus 1, d2, d power minus 2. So that is because minus, the powers are minus taken to denominator. For that reason, the pi 2 term is equals to mu by rho omega d square. So coming to the third one, third pi term, pi 3 is equals to rho omega d. These are the repeating variables. The remaining variable is what now? Discharge. Substituting the dimensions of both sides of the equation. So once again, for left hand side, the pi 3 term, that is taken as 0, powers are 0. Write the dimensions of the repeating variables and the discharge on right hand side. Now for dimensional homogeneity, once again equate these powers of M, L and T on both sides of the expression or equation. So now you are getting the values of A3, B3 and C2. For example, for M, on left hand side that is 0. On right hand side, the M, L minus 3 power of A3 for density, that is taken as A3. There is no M terms on other expressions. It is taken as A3 is equal to 0. In similar manner, you have to find the powers of T as well as L. So now we have got the values of A3 is equal to 0, B3 is equal to minus 1, C3 is equal to minus 3. Substitute these powers on this pi 3 terms. There is a rho power A3, that is 0, omega power B3, that is minus 1, that is omega power minus 1, d power C1 or C3, that is equal to minus 3, that is the d power minus 3, then cube. So now finally expression is pi 3 is equals to q by the omega power minus 1 d power minus 3. That is the minus is there, for that is taken denominator, omega power 1 diameter or d power 3. That is the expression for pi 3 term. Now after getting the values of these pi 1, pi 2 and pi 3 terms, substitute these pi term values in expression. So now the functional relationship may be written as, that means efficiency is a function of dependent variable. Now the function is taken as efficiency, then that is the first phi 1 term. The second phi 2 term is what? Mu by rho omega d square. The third phi 3 term is Q, there is a discharge by omega d power 3 is equals to 0. Their efficiency is what? Dependent variable. For that reason, the efficiency of the fan is a function of other two phi terms, that is mu by rho omega d square and Q divided by omega d cube. So that is the answer for this efficiency of the fan. On this manner, some other numericals can be solved. Thank you.